All right, we are instructed to combine, so that would imply that we need to get a common denominator. All right, our LCD, everything has to be represented with what is in each denominator. So we will need a 1 plus cosine theta. We will need a sine theta. So this portion right here is missing what? 1 plus cosine theta. And this portion is missing sine theta. Right? So what we'll do is multiply numerator and denominator. So this portion will multiply. Now that the denominators are the same, they have the same terms, we can lump that all together. So that would be sine theta times 1 plus cosine theta. And then in our numerator, if we multiply sine times sine, we will get sine squared theta. And then for this portion, we can distribute the cosine theta through. So this would be plus cosine theta plus cosine squared theta. All right. Yeah. You could put the cosine squared first and then cosine theta after that. So you're saying interchange those two? That's fine. You can do that, it doesn't matter. And I was just going to get to that. Addition is commutative, so the order in which you write it doesn't matter. And as we look at that numerator, we have a sine squared, we have a cosine, and another cosine squared. So what we can actually do is combine the sine squared and the cosine squared, and sine squared plus cosine squared is equal to 1. So that equals 1. So now in our numerator, we have 1 plus cosine theta. And in our denominator, we have sine theta times 1 plus cosine theta. We have a binomial in the numerator, and we have an identical binomial in the denominator. So what will happen to those? That's canceling party, and the 1 plus cosine theta is invited. What is left in the numerator? 1. So that would be 1 over sine theta, which is equivalent to cosecant theta. All right. So the past two examples have had an answer of cosecant theta. That's not always going to happen.